In this video, we are going to discuss about pre PSPM for SP015 Set 1. So we are going to discuss 7 questions that more than half of you got it wrong. We are going to go through it and try to see how to understand the question and how to approach and solve the question. So let's look at the first question that many of you got wrong. So this is question 3. So question 3 says that you have a train initially at rest at the station. Initially it's not moving. Has a uniform acceleration of 0.20 meter per second square until it reaches a speed of 20 meter per second. So this is the first section of the journey in which a train starts from rest, not moving, slowly speed up with a uniform acceleration of 0.20 meter per second square, speed up until it reaches a final speed of 20 meter per second. So this is the first portion of the journey. Next, it travels for a time at this constant speed and then has a uniform deceleration of 0.40 meter per second square until it comes to a rest at the next station. So here there are 2 sections of the journey involved. The second section of the journey is in which the train travels for a certain amount of time with constant speed. So what is the speed when it's traveling at constant speed? It's 20 meter per second. So it will speed up from 0 until 20 meter per second, then maintains at 20 meter per second for a certain amount of time. That's the second portion of the journey. And the third and final portion of the journey is in which the train undergo a uniform deceleration of 0.40 meter per second square until it reach a rest at the next station. So it travels for a constant speed for a certain amount of time. Then after that, it starts to slow down. But it slows down constantly at a uniform rate, which is 0.40 meter per second square. It slows down at a constant rate until it reaches a stop at the next station. So the final speed after the third and final section of the journey should be 0 meter per second square. So the distance between the 2 stations is 3000 meter, and we are asked to find the time taken by the train to travel between the 2 stations. So let's try to draw a diagram to keep all the information we have in a single diagram. So we can split our journey into 3 portions. So let's put 3 dots over here. So the first portion of the journey, the object starts at rest, so 0 meter per second square. Then after that, it travels for a certain distance until it reaches another point. And at that point, its final speed is 20 meter per second. Okay, so this is the first portion of a journey in which the object is speeding up. So let's try the acceleration to be 0.20 meter per second square. After that, the train will continue to travel with constant speed. So you should expect the initial and the final speed for this second section of the journey to be the same. So this second section of journey, it maintains at 20 meter per second. So we know because the speed never changed, therefore we know the acceleration should be equals to 0. So for the second section of the journey, the acceleration is 0. Then for the third section of the journey, the train will continue its journey, but this time it will slow down. So slow down, in this case, the acceleration will be opposite the direction of the motion, therefore it should be in the negative direction. Negative 0.40 meter per second square. Okay, we assume the motion to be in the positive direction, then because you want to slow it down, the acceleration should be in the opposite direction. Therefore, that's the negative direction. Therefore, you get a negative for your acceleration. And now you know that this object will come to a stop at the end, which is the next station. So the final speed should be 0 meter per second. And this is the third section of the journey. So now they tell you also that the distance between the 2 stations is 3000 meter. So let's label that in as well. So this is 3000 meter. Okay, so we extract all the information we have from the question, we bring it into this one single diagram here. Then later when we are doing our solving our problem, we can just base it on this diagram over here. Okay, so we are asked to find the time taken. So we need to know the time taken for the first section of the journey, second section of the journey, and third section of the journey. So let's try and figure out one by one. So let's focus on the first section of the journey. what we can do is we can write down the SUVAT for the first section of the journey. So SUVAT for the first section of the journey. We don't know the distance for we don't know the displacement for the first section of the journey, so leave it blank. The initial speed, initial x component of speed, or initial speed can. Okay, initial speed 0 meter per second, final speed 20 meter per second. The acceleration is 0.20 meter per second square. And the amount of time we are not sure. We want to find the amount of time, so we are interested with this value, and we are given value of u, v, and a. So we want an equation that has u, v, a, and t inside in order to find the time taken for the first part of the journey. So the equation will be v1 equals to u1 plus a1 t1. This equation here has v, u, a, and t, which is v, u, a that we have and t that we want to find. So now let's perform our substitution. We have 20 meter per second, 0 plus 0.20, and the amount of time we keep it as t1. We want to find it out. So if you plug it into your calculator, I believe you should get t1 to be equals to 100 seconds. So this journey from here to here takes 100 seconds. And because, let's stop here. Let's move on to the second section of the journey. Second section of the journey, you can also write your SUVAT as well. Oops. PAT. So we don't know the distance is how much. Again, for the second section of the journey, we don't know how much is the distance. So leave it blank. We know that the initial and final velocity are 20 meters per second. Then the acceleration is therefore 0 because the velocity never changed throughout the second portion of the journey. So you want to find the time. But if you want to find the time, it is a must for us to find the distance first. We need to find the distance first in order for us to find the time. Why is it so? Because the speed never changed. If the speed never changed, even though here you see there's 3 information, but because the speed never changed, technically you are only having 2 information. It's either you can think of it like this: it has initial speed of 20 meters per second and it has acceleration of 0. Using these 2 information, you derive the idea that the final speed is 20 meters per second. So technically there's only 2 independent information. So if you have 2 information, technically you have not enough information to find your time. What you need is you need to find the distance, the displacement over here first. So you have enough 3 information, then only you move on to find the time, the 4th information. Okay, so how do we find the distance over here? Well, they tell you that the total distance over here is 3000 meters. So if you are able to find the distance of the first portion of the journey and the third portion of the journey, then probably you can take 3000 minus the distance of the first part and the third part, and you can find the displacement for the second portion of the journey. So let's try to find S1 also. So we'll do our calculation here. How do we find S1? We are given information about U1, V1, and A1. So if you want to find S1, the equation should have SU, V, and A inside. So the equation will be V1 square equals to U1 square plus 2A1 S1. So this is the equation. Let's plug in our value. 20, 0 square, 20 square plus 0.20 S1. So if you plug this in into your calculator, I believe you get the displacement for the first portion of the journey to be 1000 meters. So this portion of the journey here, it's 1000 meters. Okay, you will set aside the second portion of the journey because you don't have enough information. But let's move on to the third portion of the journey. Probably there we can get more information about the second portion of the journey. So for the third portion of the journey, let's write it as S3, U3, V3, A3, and T3, SUVAT. So again, we don't know the displacement for the third portion of the journey, but we know the initial and final velocity. The initial velocity is 20 meter per second. The final velocity is 0 meter per second. So it slows down at a constant rate of negative 0.40 meter per second square, and the amount of time is what we are interested in. So we want to find the time, and we are given information about V, U, and A. So the equation that we can apply in order to determine the time will be V equals to U plus AT. So this equation here contains VUA that we have the information and time which we want to find. So now we perform our substitution. 0, 20 plus negative 0.40 times the time for the third portion of the journey. So if we perform our calculation using a calculator, I believe we should be able to get the answer of 50 seconds. Okay, so if we would like to summarize everything back into the diagram, this portion here takes 100 seconds to complete, whereas this portion here takes 50 seconds to complete. But what is the distance? What is the displacement for the third portion of the journey over here? Let's try to figure it out. We want to determine the displacement as 3, and we are given information U, V, and A. So we can use the equation of V square equals to U square plus 2A AS, AS. So if we plug in our value, we have 0 square equals to 20 square plus 2 negative 0.40 displacement for the third section of the journey. So if you plug it into your calculator, you get that the displacement for the third portion of the journey should be 500 meter. Okay, so from here we are able to know that here it's 500 meter. So if we know the first portion of the journey takes 1000 meter and the third portion of the journey takes 500 meter, we know the total distance for the whole journey is 3000 meter. We are able to find the missing portion over here. We are able to find the displacement for the second portion of the journey. So how do you find the second portion of the journey? We can do S1 plus S2 plus S3 is equals to 3000 meter. That's the total distance for the whole journey. You know that S1 is 1000, S2, S3 is 500. So if you perform a calculation, you get that the displacement for the second portion of the journey should be equals to 1500 meter. So you can fill this in, 1500 meter. And now you want to find the time for the second portion of the journey in order to sum it up with the first portion and the third portion's period. So you can add them all up to get the total time taken for the train to travel between the two stations. So we now know that it's 1500 meter. So in order to find the time, and we have S, you can take U, you can take A, you can take T. Okay, then there will be S equals to UT plus half AT square. Okay, you should not have an equation that has U, V, and A inside, because U, V, and A are technically two information only. You derive the third information based on the first two information. You know the initial, you know the acceleration, therefore you know the final. So they are not three independent information, they are just two independent information and one inference based on the two independent information. So your equation should either have U and V, S and T inside, or S, U, A, and T inside. Okay, it should not have all three of these things inside, because all three of these are dependent on each other. Okay, so the distance is 1500. U is 20, the amount of time is T2 plus half, we know the acceleration is 0, so the T square is none of our constant at the back, so this part will be 0. Therefore, if you perform a calculation, the second portion of the journey will take how much time? It will take 75 seconds. So now we have obtained the time for 3 portions of the journey. Let me write it down here. So the time that you obtain over here will be T1, T2, and T3. So it's represented over here. So you want to find the total time taken for the whole journey. It will be just sum of all of these value together. Okay, so let's try to do that. So the time taken. Oops. The time taken will be equals to T1 plus T2 plus T3. So all three of these can be added up together. So you have 100 plus 75 plus 50, and therefore you are able to obtain an answer of 225 seconds. And well, if you look over here, the question here has no 225 seconds, so I believe the nearest one will be 230. So in the case of an exam, you cannot find an answer, then it's probably the nearest answer. Okay, we should probably change this to 225 seconds. So that's how you solve the first question. How you solve question 3. Again, you look at this situation here is actually quite a elaborate situation. There's a lot of portion of journey. But if you look at it, I analyze it step by step by first drawing a diagram. I draw a diagram to consolidate all the information I have in the diagram. Then for each portion of journey, I determine the SUVAT, I determine the SUVAT, I determine the SUVAT. Then based on what I have and what I don't have, I use the appropriate equation to get the value that I want. Okay, so it is always a systematic process. You always need to visualize the situation first, then analyze it portion by portion. First, you analyze the first portion of a journey, second portion of a journey, then third portion of a journey, step by step. Okay, so that's how you solve question 3. Question 8. A 5 kg block slides down a rough plane, so we should expect this plane here to have friction, and because it is sliding, you should expect that it's a kinetic friction. So a 5 kg block slides down a rough plane which is inclined at 30 degrees as shown in the diagram below. So you can see here this inclined plane here has an angle of 30 degrees. So the block accelerates from rest and achieves a speed of 2 meters per second after moving through a distance of 2 meters along the inclined plane. So the block here will slide down. While it is sliding down, it should speed up. So it speeds up from v equals to 0 to a speed of 2 meters per second. So it's speeding up. So this journey here will be 2 meters along the inclined plane. So later we will need to label this diagram to make it more complete. Okay, then they ask for the coefficient of kinetic friction between the block and the plane. So let's try to fill up this diagram over here. The block should be moving down a distance of 2 meters. So later it might appear around here. So this journey here is 2 meters. And initially it should be 0 meter per second because it is at rest. Then finally it should be 2 meter per second after finishing this 2 meter journey. Okay, so how do we solve this problem here? We know that it's an inclined plane. We can choose to solve it using the idea of work energy theorem. Okay, and I think you can also solve it. Work energy theorem is the best way to solve it, because if you look at this situation over here, the situation involves a change of speed. So the change of speed is from rest to a speed of 2 meters per second. So this is one of the aspect being given, the speed. Then they also give you something, the distance of the journey, which is the displacement. So to relate the speed and the displacement, you can actually relate it back to your kinematics of linear motion. But if you choose to not do so, what you can do is you can relate the speed to kinetic energy. If you relate the speed to kinetic energy and you relate the distance to work done, then work done and kinetic energy can be related together through the work energy theorem. And so we are going to try to do this question using work energy theorem. Okay, so work energy theorem tells us that the total work done. It's always a total work done. It's not work done by any other forces. It's the total work done that will be equals to the change in kinetic energy. Okay, this is work energy theorem. There's no other version of work energy theorem. Work energy theorem is total work done equals to the change in kinetic energy. There are some others like change in potential energy. That one we don't call it as work energy theorem. It's just that the work done by conservative force is equals to the negative change of potential energy, or the work done by non-conservative force is equals to the change in mechanical energy. So those are not exactly work energy theorem. You read in books, work energy theorem is total work done equals to change in kinetic energy. Okay, so since we are going to look at total work done, that means we need to know what are all the forces that are acting on it. Then only we are able to find the work done by all of these forces. Only we are able to find the total work done. So let's start by drawing a free body diagram for the situation now. We use this dot here to represent the object, and we will draw two axes, one axis along the inclined plane and one axis perpendicular to the inclined plane. So let's call this y, let's call this x. Then we know that we will ask ourselves the 5 questions in order to determine what are the forces acting on the object over here. The first question is whether the object has mass or not. Yes, it's a 5 kg block, it has mass, therefore there will be weight will be pointing downward. Second question to ask whether this block over here is attached to any strings, ropes or cables. No, it's not attached to any rope, strings or cable, therefore there will be no tension acting on the block over here. Third question, is there any force being explicitly mentioned or explicitly being labeled or in the diagram or in the situation? Well, they didn't mention anything about forces, so you should expect there should be no external force acting in this situation over here. Fourth question to ask, is the object in contact with any surfaces or not? Well, this object here is on the inclined plane, so definitely it is in contact with the inclined plane. So you should expect there should be a normal force exerted by the inclined plane on the block over here. The block is in contact with the inclined plane, therefore the inclined plane should exert a normal force on the block over here. So what is the direction of the normal force? Well, always remember that the normal means perpendicular. So the direction of the normal force must be perpendicular to the surface. So this is perpendicular to the surface. Whether it's pointing up or down, again, remember the idea of push. Normal force never pull, normal force always push. So if the inclined plane is pushing on the block, it should be pushing this way, right? If it's this way, it will be pulling the block already. Normal force always push, so this is pushing on the block. So the direction of the normal force should be pointing this way. Okay, then the next question that you need to ask will be whether this surface in contact is a rough surface or not. Well, it is a rough surface. It's mentioned here in the question, and you know it is sliding along the rough surface. Therefore, you should know that there should be a kinetic friction acting on the block over here. So let's label it here, kinetic friction, F subscript K. So we ask ourselves the 5 questions. That means we have finished label our free body diagram. So this is a complete free body diagram for this block over here. All these forces are forces that are being exerted on the block at this moment over here. So we know that there will be work done contributed by the kinetic friction, by the normal force and the weight, and all of them, sum them up, you get the total work done. So that means work total will be equals to the work done by the kinetic friction plus the work done by the normal force plus the work done by weight. But because we don't want double W inside, we change it to gravity. Work done by gravity equals to the change in kinetic energy. Let's call this Kf minus Ki. Okay, so now we can start to substitute all the individual work done. We can do it like this. We can say work done by the kinetic friction will be Fs cos 180 degree. Why is it so? Because if you look at the free body diagram, you know that the displacement is happening in this direction over here. So if you look at the diagram, the kinetic friction and the displacement are in opposite direction. So cos theta over here, the theta represents the angle between the force and the displacement. So F and S, the vector F and the vector S are in opposite direction. So the angle should be 180 degree. So this is the first one for the work done by kinetic friction. Next, we have the work done by normal force. The work done by normal force, well, without space, it should be ns cos, well, it's 90°. If you can see that, this normal force here is perpendicular to the displacement. The displacement is along the inclined plane, whereas the normal force is perpendicular to the inclined plane. So both of them should have an angle of 90° in between them. Okay, let's move on to the third one, which is the work done by gravity. Okay, work done by gravity here, we know work done, it will be weight times the displacement times the cosine and the angle between them. We know that over here, this is 30°. Okay, so the angle between the displacement and the weight here should be this side over here. So this line and this line forms a 90°. This is a 90° angle. So 90° minus 30°, you get 60° over here. Therefore, it should be cosine 60°. Okay, so then it will be equals to half mv square minus half mu square. Okay, so let's tidy up some things over here. We know that cos 180° will be equals to -1, and the cos 90° will be equals to 0. So with that, we can simplify and do our substitution together at the same time. The friction is what we want to find because later we'll link it to our coefficient of kinetic friction. So we leave it as F. The distance traveled is 2.0. So you multiply by -1 over here. So therefore I put a negative sign in front. Then it'll be plus 0 because n times s, even though there's a value, but because you times 0, you get 0. Next, plus mgs, m is 5 kg, g is 9.81. The displacement, magnitude of displacement is 2.0 cos 60°. Then it'll be equals to, I'm going to factorize out the half and m. So half and m, then inside this bracket, there should be v square minus u square. Okay, so v square is 2.0 square minus 0 square. Okay, so look at this equation over here. Everything is being substituted in except for the kinetic friction. Let's be a bit clearer. Let's label this as Fk. So the only thing left is the kinetic friction. So we should be able to determine the kinetic friction just by typing everything into the calculator. So the kinetic friction obtained should be 19.525 Newton. So you have determined the kinetic friction and your final destination will be the coefficient of kinetic friction. So how do you relate between the kinetic friction and the coefficient of kinetic friction? You know that you have to come back to the idea of kinetic friction is equals to the coefficient of kinetic friction times the normal force. Therefore, you have to determine the magnitude of the normal force in order to determine the coefficient of kinetic friction. So how are you going to determine the normal force over here? Well, you just need something related to chapter 4. You need to do your Newton's, you need to use your Newton's law of motion to analyze the y dimension. You know that the object is sliding down the inclined plane. It is not moving up or down with respect to the inclined plane. It is not moving higher. It's not leaving the inclined plane or it's not going into the inclined plane. So in the y dimension, it is at rest. Because the y dimension it is at rest, therefore using Newton's law of motion, you know that if it's at rest, you can analyze the y dimension using Newton's first law. So Newton's first law tells you that the sum of force, in this case in the y dimension, should be equal to 0 because it is at rest in the y dimension. Therefore, the net force acting in the y dimension should be balanced, or the up must be balanced by the down. Okay. So we can take normal force minus, we need to resolve this. Resolve this into this component, which is W cos theta, cos 30°. And this one should be W sine 30 degree. The weight, this is not work done. This is weight cos 30 degree and weight sine 30 degree. So now we have resolved it. We know that the normal force will be balanced by the cosine 30 degree of the weight. So minus weight cosine 30 degree equals to 0. Therefore, we know that normal force is equals to, let's call it straight away, mg cos 30 degree. So if you perform your substitution, 5 kg block, gravitational acceleration 9.81, cos 30 degree, you get an answer of 42.48 after rounding up to 2 decimal places. So now you can just substitute everything in. 19.525 is equals to the coefficient of kinetic friction times the normal force. So normal force is 42.48. Therefore, you'll be able to calculate the coefficient of kinetic friction to be equals to 0.46. So this is how you obtain the coefficient of kinetic friction, and the answer should be A. Okay, so this is how you use the work energy theorem. It always starts from total work done equals to change of kinetic energy. So in order to determine the total work done, you have to draw a free body diagram to see what are the forces acting on it. Okay, if you determine all the forces already, you find the work done for each of the forces, and from there you can continue to do your calculation to obtain what you want. Okay, for forces, if the object is not moving or at rest in that dimension, then we analyze it using Newton's first law. If it's moving in constant velocity in that dimension, first law as well. But if it's moving with a non-zero acceleration, like in this case in the x dimension, then you can analyze it using F equals to ma, the Newton's second law. Okay, so this will be question 8 over here. Let's move on to the next question. A 5,200 kg cable car is pulled a distance of 360 meters up a hill inclined at 12 degrees from the horizontal. Okay, so it's and we definitely need to draw it out in order to understand the situation clearly. And they ask for the change in potential energy, delta U of the car. Okay, so you have a cable car. Let's represent it with a rectangle. So this is a cable car. And this cable car is being pulled a distance of 360 meters up a hill inclined at 12 degrees from the horizontal. So if your hill is something like this, if your hill has an angle of 12 degrees from the horizontal, then this cable car here is being pulled a distance of 360 meters until you reach a certain final position. Okay, so if you are asked to find the change in potential energy of the car, you know that here the potential energy relevant to the situation is the gravitational potential energy, because this is definitely not elastic potential energy. There's no spring involved. There's only change of height involved. So if there's change in height involved, you know that there will be change in gravitational potential energy. So to find the change in gravitational potential energy, you definitely need to know the change in height first. So what I'm trying to say here is you have to determine what is the change in height from here to here. So this is the distance that you need to determine. But I believe you are able to see that it is actually a triangle being formed right now. You have your hypotenuse, you have your adjacent, and you have your opposite. And the angle should be 12 degrees Celsius. 12 degrees Celsius, 12 degrees, sorry. So now you should find the change in height using trigonometry. And once you have determined the change in height, you should be able to find the change in potential energy. Okay, so the change in potential energy will be equals to mg change of height. So in order to find the change of height, you know that it will be equals to the distance traveled sine 12 degrees. Okay, if you're not sure, draw a triangle. If this is your angle, then this is opposite, this is hypotenuse, this is adjacent. So you have this, you want to find this, therefore you need to use OH. So what is OH? It's a sine. So sine theta something OH. So therefore you need to use sine theta. So therefore you put sine over here, then you put your hypotenuse, shift it up, hypotenuse sine theta equals to opposite. So opposite here will be delta h, hypotenuse will be the distance traveled over here. Okay, so now it's a matter of substitution. It's a 5,200 kg cable car. The gravitational acceleration is 9.81. Then the distance traveled is 360. Then it will be sine 12 degrees Celsius. Degree, sorry. Okay, so if you calculate everything here, I believe you should get the answer of 3.82 times 10 to the power of 6 joule. Okay, always remember, if you're calculating anything with joule, right, make sure every variable is in SI unit. Okay, if you have length, then make sure it's in meter. If you have time, make sure it is in second. Okay, then only you are able to determine the energy in the unit of joule, because joule is actually Newton meter, so it's actually kg ms negative 2 times meter. Okay, so everything is in SI unit if you are doing things involving energy. Okay, so we know the answer will be B over here. Okay, so that's how you solve question 10. Question 13. The gravitational field strength at the surface of the Earth is G. So this is the 9.81 that we usually say. So if the height of a point from the surface of Earth is 2 times the radius of the Earth, so the height itself measured from the surface of the Earth is 2 times the radius of the Earth. So the height should be equals to 2r subscript e. Okay, then the gravitational field strength at this particular point should be how many times of the gravitational field strength at the surface of the Earth. Okay, let me use the diagram to illustrate the situation better. So they say that the gravitational field strength at a particular point on the at any point on the surface of the Earth, the gravitational field strength will be equals to G. Okay, whereas on another point, another point, say somewhere here, this point here as a height which is equivalent to 2 radius of the Earth. Okay, so again, this is the radius of the Earth. So at a certain point, which has a height of 2 radius of the Earth from the surface of the Earth, what is the acceleration due to gravity or the gravitational field strength at this particular point? Okay, so you have to express it in terms of the gravitational field strength at the surface of Earth. So we are going to, this is similar to a ratio question. So what we are going to do is we are going to build the equation, one for the surface case, one for the point case. Okay, so if you're on the surface of the Earth, your acceleration due to gravity will be equals to G m, the mass of Earth, let's call it big M, divided by r subscript e squared. Okay, let's label this m subscript e. So this is the gravitational field strength at the surface of the Earth. So we can see here we sub in the r to be the radius of the Earth, because we are looking at the gravitational field strength at this point. And this point has a distance of r subscript e from the center of the Earth. Okay, so we also know that this point we also name it as G, which is a 9.81 that we usually do in chapter 4 or chapter 4. Okay, so now we change our focus to look at this point over here. This point has a distance of 3 radius of the Earth from the center of the Earth. It has a distance of 2 radius of Earth from the surface of Earth, but it has a distance of 3 radius of Earth from the center of the Earth. Okay, so let's call it point of interest. So at this point of interest here, the acceleration due to gravity or the gravitational field strength is also gme, but this time it's over r squared. Okay, we know that r is equals to this part over here, and it is equivalent to the radius of the Earth plus the height. Okay, so let me just write like this: radius of the Earth plus the height will be equal to distance of the point from the center of the Earth. So it's equals to radius of the Earth plus the height, and the question tells us that the height of the point from the surface of Earth is 2 times the radius of Earth. Therefore, we know that we should substitute the height to be equals to 2 times the radius of the Earth. So if you add it up, you should get 3 times the radius of the Earth. And that should be the distance from the center of Earth. Okay, so now if you substitute everything inside, you should get 1/9 gm over radius of the Earth square. Okay, so this is the gravitational field strength at the point of interest. So if you want to compare this thing, we know that this part over here and this part over here are the same, so you can substitute g to replace this g mass of Earth divided by radius of Earth square. So it becomes 1/9 g. So we know that the gravitational field strength at this point is equals to 1/9 of the gravitational field strength on the surface of Earth. So this is the answer. Okay, you just need to, this is similar to a ratio question. When you're doing a ratio question, always start by building an equation, then find out what's the relationship between the first case and the second case. In this case, the surface case and the point case. What is the difference? The difference is the distance from the center of Earth. So if you change the distance, you find out the new, you build these two equations, one for the surface equation, one for the point equation, then you find the relationship between them by relate them together, substitution. Okay, so this is how you solve question 13 over here. Let's move on to the next question. Question 19. The equation for a progressive wave is y is equals to 6 cos 20t minus 4x. So as the equation of another progressive wave, which has twice the amplitude and frequency. So the amplitude will be twice the original amplitude, the frequency will be twice the original frequency. And this wave here, this progressive wave, is also moving in the same direction. So we are going to build another equation, but based on the first equation that we have here. So let's copy down the first equation first. Y is equals to 6 cos 20t minus 4x. So if you compare it with the displacement equation for SHM, and not SHM, this is for progressive wave, sorry. So if you compare it with the equation for progressive wave, you know that the amplitude is equals to 6, the omega is equals to the angular frequency or angular velocity is equals to 20, the wave number is equals to 4. Okay, if you see here, I haven't attached any unit to the amplitude, I haven't attached any unit to the angular frequency, I haven't attached any unit to the wave number. Why? Because it didn't state this is where x and y is in cm or in meter, we are not sure. Whether time is in second or in minute, we are not sure as well. So for now, I'm not going to attach any unit to these values over here. I'll just leave it as it is until I know whether it's cm or meter. Only I attach the unit to it. But for now, we won't know. Okay, so we know that the new situation here, we have twice amplitude. So I can say the new amplitude will be equals to 2 times the old amplitude. Therefore, it should be equals to 2 times 6 equals to 12. You also know that the frequency will be twice the original frequency. So how do you relate the new to the old? Okay, so you know that the new angular frequency will be equals to 2 pi times the new frequency. You know that the new frequency is equals to 2 times the old frequency because they say the frequency is twice the frequency. Therefore, it's 2f over here. Now, if you continue, you know that you take out the 2 over here, then you can reshuffle it to become 2 pi f over here. And this thing is just the old angular frequency. So know that the new angular frequency is equals to twice the old angular frequency. and you know that the old angular frequency is equals to 20. Therefore, we know that the new angular frequency is equals to 40. Okay, so if now you want to build the equation, you can build equation y prime equals to a prime cos omega prime t minus k prime x. Technically, the y should not have any prime. The y is just a variable here. Okay, so if you substitute in the value, it will be y equals to 12 cos 40 t. Then you might be wondering, oh, the k they didn't mention it changed, right? So I just put back negative 4x inside because they didn't mention the wave number change. But if you look into the option over here, there's no option that has 40t minus 4x inside. If you want 4x, then it has to be 20t. This is wrong also. So your answer has 40, so it must be either this or this. But both of them is not 4x. So something is wrong here. Means like the wave number will have to change as well. So if they didn't tell you how the wave number will change, what you can do is you can assume, okay? Here they should state it more clearly, but you can assume the old progressive wave and the new progressive wave are moving in the same medium, are traveling in the same medium. Why do you need to make this assumption here? Because if you are traveling in the same medium and the properties of the medium are the same, you can therefore know that same medium means by the wave speed should be the same. The wave propagation velocity should be the same. Okay, this is an assumption that we take. They should have stated in the question, but since they didn't state it and we still need to make progress, we assume that the old and new progressive wave are traveling in the same medium. So for the old progressive wave and the new progressive wave, because the medium is the same, therefore they should both share the same wave propagation velocity. So what is the wave propagation velocity for the old case? You can find it by using v equals to omega divided by k. The angular frequency for the old case is 20. The old wave number is 4. So you know that previously the wave propagation velocity is just 5. Okay, but now if you are in the new situation, it will be omega prime k prime. We say that the v should be the same for both cases, so we are going to use back 5 over here. So 5 will be equals to the new omega is 40, so we will be able to find the new wave number. So the new wave number we can find it to be equals to 8. So we know that the new amplitude is 12, the new angular frequency is 40, the new wave number is equals to 8. Therefore, we can make correction to the new equation that we obtained by changing it to be 8. Okay, they also mentioned in the question that it's moving in the same direction. So what will happen if it's moving in the same direction is that the sign in front of the kx will remain the same. But if you happen to change to move in the opposite direction, you have to change the sign in front of kx to the opposite sign. If it's positive sign previously and it now move in the opposite direction, you have to change it to negative sign. And if it's negative sign and they say they're traveling in the opposite direction, you have to change it to positive sign. Okay, the negative or positive in front of the kx decides the direction of propagation of the progressive wave. So now once we have determined the amplitude, determined the angular frequency, and determined the wave number, we determine all these 3 values already, we should be able to find the answer for this question to be B. Okay, so we are making an assumption where the 2 progressive waves are traveling in the same medium in order to assume that they have the same wave propagation speed or velocity. Okay, so this is how we solve question 19. So let's move on to the next question. A transverse progressive wave travels along a rope. So this is a rope and you are sending a progressive wave by shaking the one end of the rope over here. So by shaking one end of the rope over here, you are sending a continuous wave over to the right. Okay, a transverse progressive wave travels along a rope where the NO is waved up and down 20 times in 5 seconds. So that means you undergo 20 oscillations in 5 seconds. That means each second you should undergo 4 oscillations. Then 5 seconds you complete 20 oscillations. So this is trying to tell you the frequency of the progressive wave over here. How many times you oscillate per second, that will be the frequency of the wave produced. Okay, the wave produced is as shown in the figure here. So what is the speed of the wave? We are asked to find the speed of the wave. We know here the value provided is the frequency. So what we need now is the wavelength. Well, how do we determine the wavelength? Well, they already give you the wave pattern. They give you some length measurement. You should be able to determine the wavelength. So let's try to do that. We know that it's 20 times in 5 seconds. So that means that the frequency, you can find it by taking the total number of oscillations divided by the amount of time needed to finish that number of oscillation. And from there, you should be able to find that the frequency is 4 Hertz. So you know that in order to determine the speed of the wave, you need to use V equals F lambda. You already have the frequency, which is 4.0. Now what you need to find is the lambda. Okay, so for this, in order to determine the lambda, we have to refer back to the diagram over here. To be more specific, we have to determine how many complete wavelength is found in this wave pattern over here. We know that the total length of this wave pattern is 0.34 meter, but this 0.34 meter is equivalent to how many complete wavelength? Whether it's 1, 2, 3, or 3.5, we need to determine that. How do we determine that? Well, count. Okay. So we start from here. So every time we come back to the trough, that means we finish one oscillation. So this is one oscillation until here. This is first wave cycle. It should be more proper to call it as wave cycle. First wave cycle, second wave cycle, third wave cycle, fourth wave cycle. So the fourth wave cycle will stop here, but there's an extra 1/4 of an oscillation over here. This is 1/4 of an oscillation. How do you check? Well, repeat one more, repeat one more, repeat one more, then you complete oscillation. This is 1, 2, 3, 4. So this is 1 out of 4 parts of a complete wave cycle. Therefore, we know that it's 1/4 of a complete wave cycle. Okay, so there is 1, 2, 3, 4 plus a 1/4 over here. So it's 4 to 4 and 1/4 complete wavelength is equivalent to 0.34 meter. So we can change it into improper fraction. That will be 17 divided by 4. Lambda equals to 0.34. So now you are able to find the lambda just by moving around the value. I believe you should be able to get the answer of 2 divided by 25 meter. So now knowing that, you can substitute it inside here. And I believe you should be able to get the answer of 0.32 meter per second. So this is the answer. Okay, so you have to be careful. Some of you might count this as 4 complete wave cycle, but you ignore the last part over here. Well, you have to make sure you start from where, then you trace back to the same phase. Then you consider to finish one complete wave cycle. So this is 1, this is 2, this is 3, this is 4. There's an excess over here. So this excess will determine whether it's how much of a complete wave cycle. In this case, it's 1/4 because it comes back to the equilibrium position. So this is 1/4 of a complete wave cycle. So from there, you are able to determine the actual wavelength through some proportions. Okay, so that's how you solve question 20 over here. Next. Question 22. A tube P is closed at one end and open at another end. Another tube Q is open at both ends. So you know that tube P here is actually a closed pipe. Tube Q here is actually an open pipe because it's open at both ends. So tube P and tube Q are of the same length. So therefore, you know that LP is equals to LQ. So now they ask what is the ratio of the frequency of the first overtone of tube P to tube Q. So later we need to find the frequency of the first overtone for P divided by the frequency of the first overtone for Q. Then that ratio will be our answer. So let's try to draw two tubes to represent tube P and tube Q. So the first tube here will be tube P. It's a closed pipe. So another tube here will be tube Q. We know that they are the same length, so we try to match the length for the two pipe. This one should be open. Open at both ends. That's the property of Q. Okay, so now we are asked to find the frequency of the first overtone for tube P and tube Q. Well, how do you find the first overtone? Well, first overtone is the first tone after the fundamental tone. It's the first tone after the fundamental tone. So what do? We can start by drawing the fundamental, by sketching a fundamental tone first. And after that, go up one step by introducing a note into the situation. Okay, so we know that here it must be a note because there's a wall over here. When they have a wall over here, the particles over here cannot oscillate because there's limited space. It cannot vibrate freely. So here you should expect there's a note. Whereas the air particles over here has plenty of space to oscillate. So you should expect this part of the tube here to be an antinote. So if this situation here obeys the logic for antinote and notes, because the notes are not side by side with another notes, the antinote is not side by side with another antinote. So this situation is logical. So this will be our fundamental tone. But now they ask for the first overtone. Therefore, we introduce one more note into the system over here. Every time you go up by one overtone, you introduce a note inside, then you create the next overtone. Okay, so now they ask for a first overtone, so you introduce one note inside the system over here. So if you put your note over here, then something will be wrong because note and note cannot be side by side. Therefore, you know that in between these two notes, there must be an antinote. So let me arrange it nicer. You know that you want to introduce a note in order to go to the first overtone. But you know, since that note and note cannot be side by side, you need to introduce a antinote in between the two notes. So this will be the first overtone. So the pattern of a first overtone will be note will be at the equilibrium. The antinote should be at the maximum. So if you draw a line to connect everything, it should be something like this. Okay, so if you want to know this is the which harmonic, whether it's the first harmonic, second harmonic, or third harmonic, that one you should see whether the fundamental pattern, the fundamental standing wave pattern appears how many times, repeat how many times in this sequence over here. Let's try to draw the fundamental pattern. Okay, if this is a tube, the closed pipe, and you want to draw the fundamental tone, you start by the basic. You know this is the basic. If you don't introduce a note inside, you are not creating an overtone. It's just fundamental. So now you know that the wave pattern will be something like this. Okay, so in order to find this is the which overtone is this, what you can do is you can find how many times this pattern appears in your standing wave pattern. Well, this is the first time the fundamental pattern appears once. Then you can see the next time it appears, it's here. This is the second time it appears. The same pattern, like this kind of shape appears once, twice. Then the third time it appears will be here. So since the fundamental pattern happens 3 times in this overtone pattern, you know that this is actually a third harmonic. Okay, just extra knowledge, just in case you are not able to differentiate what is harmonic, what is overtone. So this is a third harmonic, but it's the first overtone. Why is it the first overtone? Because this is this is the second less, the fundamental tone is the simplest standing wave you can produce in the pipe. So first overtone is the next simplest one. Okay, one step higher than the fundamental. That's the meaning of overtone. How many times over the fundamental? First overtone means by the first time going over the fundamental tone. So you see that if you want to go over the fundamental tone for the first time, your fundamental pattern will have to appear 3 times. Therefore, it's a third harmonic. Okay, so let's look at the open pipe over here. Open pipe, we know that both ends, the particles are free to move. So know that both ends should be an antinote. You know that antinote and antinote cannot be side by side, so therefore you must introduce a note in between. So this will be the most basic pattern that we can have for an open pipe. So this will be the fundamental tone for an open pipe. So let's draw it over here. The fundamental tone will be looking like this. Antinote, note, antinote, antinote, note, antinote. So this is this is called the fundamental tone. This is called the first overtone. Okay, so you want to go one step higher, you want to go one step over the fundamental tone. So what do you need to do to this fundamental tone? You introduce a note inside the pattern. So if you want to introduce a note inside the pattern, you have to bring in an N inside. But now this sequence here is not correct because you have note and note side by side. Therefore, you know that you have to introduce an antinote in between them. So you have to modify your pattern to be, you know that there will be 2 notes inside the pipe. But you need to know that these 2 notes cannot be side by side. You need to introduce an antinote in between them. Therefore, you will know that the pattern will look something like this. Antinote, note, antinote, note, antinote. Of course, the other side will be this. Okay, so this is the first overtone for a curve for an open pipe. Okay, let me organize my things over here. This is closed pipe. This is open pipe. Okay, but what harmonic is this pattern over here? In order to determine which harmonic is this, you have to see how many times the fundamental pattern appears. Okay, so the fundamental patterns looks like this, like a X, like a cross. So you see how many times it appears? The first time it appears is here, then the second time it appears it's here. Therefore, you know that the fundamental pattern actually appears 2 times in the first overtone. If it appears 2 times, that means it's the second harmonic. Okay, or in this case, you can say the N is equals to 2. This one is N is equals to 3. Okay, so this is how to differentiate between overtone and harmonics. You have to be able to differentiate them clearly. So let's actually now move back to the question and find what is the ratio of the frequencies of the first overtone of tube P to tube Q. Okay, before we rush into the idea of frequency, let's analyze the pipe over here. We can see that this pipe over here consists of 3/4 of a wavelength. Okay, let me draw it out. A complete wavelength will go like this. This is a complete wavelength, but your pattern chops here. So that means only 3/4, only 3/4 of a wavelength appears inside the tube. Only 3/4 of a wavelength for P appears inside the tube. So you know that the tube has a length of L. So 3/4 of the wavelength is equals to the length of pipe P. Okay, so this is pipe P. Whereas for the situation of pipe Q, how many times does a wavelength how many times you see it appears. So a complete wavelength will start from here, goes here, then come back up. Okay, so this is exactly one complete wavelength being fit inside the pipe. So if you have one complete wavelength fit inside the pipe, therefore you know that the length of the pipe, the length of pipe Q is exactly equals to the wavelength right now in pipe Q. Okay, if you want to be more specific, you can choose to instead of writing just P and Q, you know this is the third harmonic for pipe P. So you can write this is lambda 3 because this is the third harmonic, the wavelength of the third harmonic for pipe P. This is the wavelength of the second harmonic for pipe Q. So this is how you can write it. Okay, so you also know that V is equals to F3 for P, lambda 3 for P. So you know that V is equals to F2 for Q, lambda 2 for Q. V is equals to F lambda, just the same old equation. You know that both of these pipe here should have the same wave speed. Why should they have the same wave speed? Because you know that they are the standing wave produced are both in the same medium. Because they are in the same medium, therefore you know that pipe P and pipe Q should have the same wave speed or wave propagation speed. Okay, so now we can replace lambda 3p to be equals to V divided by F3p, whereas lambda 2q can be equals to V divided by F2q. Okay, so now perform substitution. 3/4 of V frequency 3p, 3p. Third harmonic for pipe P is equals to the length of pipe P. Okay, let's don't call it length of pipe P. We know that the length are the same, so you can just remove the P. Okay, continue. V, the wave speed, divided by the second harmonic frequency of pipe Q is equals to the length. Okay, so now once we know that, we can equate these two equations together. Say that 3/4 of the wave speed divided by frequency of the third harmonic for pipe P is equals to the wave speed divided by the frequency of the second harmonic for pipe Q. So we are asked to find the frequency of the first overtone of tube P to tube Q. So P should be up, Q should be down because it's tube P to tube Q. So P should be up, Q should be down. So we need to do a bit of rearrangement. F3P divided by F2Q. So if we make our arrangement, I believe it's going to take some time for me to think. You get 3/4. Okay, the V will cancel out, then you get 3/4 if you shift things around. So the answer should be 3/4. Okay, so the few aspects that you need to take note when you're solving this question, let me highlight it. First is you have to differentiate what is overtone and what is harmonic. Okay, overtone is how many times you go over the fundamental tone. If first overtone, that means it's the first time going over the fundamental tone. So you introduce one more note to the fundamental tone. If it's a second overtone, you introduce two more notes into the fundamental tone. You put in two more notes, then you try to add in antinote to balance it out. Okay, that is overtone. Harmonic is how many times the fundamental pattern appears in the standing wave pattern. In this case, if it appears 3 times, then it's a third harmonic. If it appears 2 times, then it's a second harmonic. The n should be following the number of harmonic, n should not be following the number of overtone. This one you have to be very careful about it. Next, you have to be aware how to compare between the wavelength and the length of the pipe. This one you have to use your understanding. There are many ways to do it. One is you can say that the distance from N to A is lambda over 4. This is fixed. The distance between the node to the next antinode should be lambda over 4, always. So this time you can see that the lambda over 4 happens 3 times. Therefore, it's 3 lambda over 4, which is what happens over here. For this situation, you can see that lambda over 4 happens 1, 2, 3, 4. 4 times of lambda over 4. That's why 4 times lambda over 4, you get lambda. That's one way of doing it. So you know that it will be equals to the length of the pipe. Okay, so that is the second thing you need to do. You need to be able to build this equation based on the diagram that you draw. Next thing, you need to be aware that because they are the same, they are air, they are like the medium is atmospheric air for both pipe P and pipe Q. Therefore, you can assume that the wave speed are the same because they are producing the standing wave in the same medium. Okay, so this is part 3. Then after that, it's just rearrangement, finding ratio, and you should be able to get your answer. So this is how you solve question 22, and that's all the questions that I want to discuss for Pre PSPM SP015 Set 1.